Computer.
Do you know what is different, like what the difference is between like psych stats versus like the sociology stats or the other stats they teach here?
Yeah, psych is clearly better.
Yeah, but like, well, yeah, but like, what, because when you look at the description, they're all exactly the same description, but they're like, you can't interchange these unless if it specifies that you can for a degree.
See, there's a social professor here that we talk trash to each other all the time about which is better, sociology or psychology.
Is it the same though?
They're pretty close. The idea is sociology is supposed to be group behavior and psychology is supposed to be individual behavior, but a lot of the literature says they're kind of like the same course. So
Okay, because like I thought it was weird because if you do like math statistics, like in the math program, it's like you have 3 prerequisites that you have to take it, and then this one only has 1 prereq, and you can test out of it. And I thought that was interesting. I'm like, why would they be different?
it must have to do with what the soc major is.
Maybe,
It must have to do with like
but then in like
the catalog.
But then in the nursing program, they're all interchangeable. So I'm like, well, psychology sounds more fun, and it has the least prerequisites.
Psychology is absolutely more fun.
I mean, I took that other psychology class with you, and that was, I didn't even need to take that. It was just, hey, that looks fun. But childhood development, that's what it was.
Child and adolescent development, yeah.
Which was funny because I took another class that was early childhood education and parent. It was the exact same class basically as the psychology, just a 12-week instead of 16.
Oh yeah, you were talking about that class. It was the exact same class,
It was
or
like
almost,
the exact same class,
almost.
so I was like, oh, I already know this, which was cool. It worked out for me. There were some differences.
Like Mike, okay, even better. Okay, great. So now we go like this, participants. Let's go make myself co-host. Now it shouldn't matter. And then, do you guys submit them?
Where are they?
Yeah.
Oh, then I hit it. I need to fix that. I got you. No, it's just me and me. And yeah. And
Anybody have any type of experiences? Or like over half of it. I scolded a child, that's about it.
Oh, that's always fun.
Well, usually parents like butt in and then it doesn't get resolved because the parents are very permissive.
Ooh, that's that style. Yes.
And
Yeah, I know what that
I'm
is.
not like that, and so we started yelling, and I looked at him, and I, with my best babysitter voice, I went, "I do not tolerate that. Do you understand?" And then he just stared at me.
Nice.
But
Exam
wasn't trying to be
2,
mean. We're just-
make available. Okay, I didn't make that available. It was in there, but it was hidden because if I make everything available.
So which one would it be?
So I got 2 things right here. So can you guys see this? So in class activities. So I have 2 things for you. I have exam 2 review. And I have exam 2 form to poster exam 2 reviews. So this is for me to grade.
Okay.
And the one below it is if you want to share your notes with your colleagues for you to benefit from your notes.
Okay.
That's optional. It's not graded. It's just basically like a poster. Like, so as soon as you submit your exam 2 review, sorry, I thought that was available. I didn't see that.
Wait, exam 2 review, 10 points. No.
Class assignment 8.
Would you prefer the review as a PDF or as?
I'll make it 30.
Or
Does that make you feel better?
Last one too?
That's gonna mess up the points. I have to change the syllabus, but I can do that.
No, it's too much. Yeah. I was just playing, but
Oh.
I'm glad you're changing it to 30 in a row.
But if I do that, then the total number of points in the syllabus has to change in terms of what the grade scale would look like. If I keep it 10, then they would be the same.
Oh, then it's fine.
no, it's
fine.
Like, it's
So
like-
it's gonna be the same thing.
It'd be the same. It'd be the same. So like, it would still help you, and it might help you more, but it would be because what I did is I added them up.
Well,
Maybe exam 3 was 30 points.
it'll be the same thing when
gotten it.
You know what I think I did? I think this is worth 10 points. And I think the worksheets are worth 30 where we go through the review.
Mm.
So that's like 40 points for both. So I can make both 20. I mean, I could play with the points, but if I change them, I have to add them to this. That's for the same thing.
Okay, so question, do you want a PowerPoint or do you want a PDF? Like which one would be easier to read on?
They'd be the same because there's a presentation mode in the PDF. I learned like in like the last couple of weeks, I know there's a presentation mode in PDFs, but you just like right click and you click present, and then it looks like PowerPoint.
Okay. Because I have both.
If your classmates want to view something on their phones, a PDF would be better because PDFs can be read on all devices, where a PowerPoint you have to be running Microsoft Office.
That's why I generally like
Shoot. Do that and probably the review and then chapter 9 if we have time, but we're okay because we only have 4 more chapters and we still got like at least 5 to 6 more meetings, so we're fine. Before November, approx. Yeah. No, we won't have Thanksgiving.
when do we stop?
Yeah.
15.
I think the 10th through the 15th are the final activities. So what'll end up happening is either we'll use that to get through all the material, and then I'll say you have a week because usually I have 2 weeks to post grades. So I'll give you past the semester to get the final in, or we'll take it that day or something, or we'll do like a review, probably a review. What I usually do for this course specifically is usually the 3rd test is taken after the semester ends because I have time to do grades. Then I give some of that time to you. I just can't give you all that time because I gotta be able to get the grades in. So I usually can extend it like a week to 10 days. 6 more visits, that's fine. So we do a review now. And if that's all we do, that's okay. Because then we can do 9, 10, 11, 12, 4 more visits. And then the 5th visit would be our review. So as long as we pace it 1 chapter or more every class after this one, we would still totally hit everything. So, yeah. I've taught this course a ton. I always get to the finish line. Sometimes we're like literally reviewing exam through the last class period. And then usually people are taking it later, but I try to like take enough time with you and answer your questions rather than like rush through it. If we spent a little less time on every chapter, we would probably finish right at the end of the semester, but I want you guys to succeed. I don't want to like be like, I don't know what an F score is. I want you to know when you get to the exam. Don't worry about that. I have really good worksheets. All the worksheets actually from like about chapter 6 on, there's at least one worksheet that's my own. And from like about chapter 8 or 9 on, it's just my worksheets. So there's, yeah,
Or maybe a question.
sure. What's up?
What if we do like for the next exam review? Or we do like partners? Or no?
I don't know. Maybe. Because that would be less presentations. That would give us more time. The only way for that to work, because I cannot assign Blackboard in groups, is you'd have to both submit to the same spot for that to work. But because it says review and not actually like doing the math, I could probably swing with that, yeah. Did you guys submit or can you submit? Oh, some of you did. Chapter 8 review. No, that's the review. Where's the exam review? Can you guys upload them?
Yeah.
You did? Okay. The 2 different spots? Oh, then maybe it's on the next page. That could be my bad. Oh, okay, cool. So I can pick people, or you can tell me which order you want to go in. You want to go, Jackie? Oh, okay. Okay. Not gonna mess up.
Like last time, I'm like. I felt so bad last time we did this reviews. I like lost my voice and I'm like, I can't present.
I think I presented for you.
Oh,
You
yeah.
did present to me and I felt so bad. I'm like, but like I literally couldn't talk.
Sure.
Stress-induced infection.
that working? Oh, that is totally working.
This other content is bad. Fine.
So if
You're
you
on
go,
this one, right?
if you go like this,
What
it,
do you do?
yep,
Oh, the
all I'm doing
arrow?
is the arrow keys.
Okay,
And then that should get the speaker. This should be, there's no real mic on this, so that it should pick it all up. And then, yeah, perfect. Okay, awesome. Obviously, if you
Okay.
go away off the map, I'll tell you.
okay,
Okay.
okay. So, I'm gonna do chapters 5 through 8 review. So starting off with chapter 5, talk about probability. Probability being the frequency of times that the outcome occurs divided by the number of possibility outcomes. And then the steps that we take to find, the steps that we take are, first we find the sample space, and then, sorry, ignore the second sample space. And then second is we find the fx. So over here, oh, okay, I kind of got messed up the little formula. So it's px equals fx divided by the sample space. And then a little hint that I added was if the numbers is close to 1, it is more probable. If the number is closer to 0, it is more impossible. And then some more of chapter 5 vocab is mutual exclusive, meaning that you cannot flip heads and tails. It must be either heads or either tails. Independent outcome, meaning that the outcome doesn't affect each other. Complementary, meaning both outcomes are equal to 1. And then conditional occurs when the probability of one outcome is dependent on the occurrence of the other outcome. Standard deviation of a probability distribution is the mean distance that all possible outcomes of a random variable deviate from the expected value or mean of a probability distribution. And then a little bit of chapter 6, we encountered some normal distribution, which is also associated with symmetrical Gaussian, and
Someone's at the door a little bit.
Yeah, right? Are they?
Someone's there.
I don't know. I thought I heard somebody knock.
Alright.
Okay, and bell-shaped distribution. The distribution is a theoretical distribution in which scores are even distributed below and above the mean, median, and mode. We also talked about the z-score, which is the value on the x-axis of a standard normal distribution. This z-score value indicates the distance and value is above or below the mean. Standard normal transformation are used to convert any normal distribution to standard normal distribution with mean of 0. Sample scores are used to locate where scores will fall in standard normal distribution. And then a little bit more are the characteristics of the normal distributions. First, needs to be mathematically defined. After, we need the normal distribution to be theoretical. And then the third step is the mean, median, and mode are all in the 50th percentile. The normal distribution is symmetrical. The mean can equal any value, whether it is a negative or a positive value. The standard deviation can equal to any positive value. And then seventh, the total area under the curve of a normal distribution is equal to 1.0, and the tail of a normal distribution are symmetric. A little bit of chapter 7, sampling distribution is a distribution of all sample means or sample variance that can be obtained in sampling distribution samples of a given size from the same population. Sampling without replacement is a method of sampling that is used when each item is not replaced before the next selection.
Fix it.
Which is totally okay, but if I just go like this, you keep going, it should get rid of the echo.
Okay. And then sampling with replacement is a method of sampling that is used when each item is replaced before the next selection. A little bit more is the sample design is a specific plan or protocol of how individuals will be selected or sampled from the population of interest. Unit-biased estimator is an example of variance when we divide the SS by n-1. Central limit theorem explains that regardless of the distribution of scores in a population, the sampling distribution of samples means selected at random from the population will approach the shape of the normal distribution as the number of samples in the sampling distribution increases. And then chapter 8, we did a little bit more of with hypothesis. Hypothesis, again, just to refresh, is a statement which is meant to explain an observation for a scientific problem that can be tested using the research method. And then null hypothesis is a statement about the population mean, which is assumed to be true. An alternative hypothesis is a statement that contradicts the null hypothesis directly by stated the actual value of the population with the less than, greater than, or equal to. 4 steps to hypothesis testing, which first one, you state the hypothesis, and then you set the criteria for the decision, then you compute the test statistics, and 4, you make the decision. Okay. And then we had some errors when trying to make our decision. So first, the decision to retain the null hypothesis is correct. Another error is the decision to retain the null hypothesis is incorrect. Another is the decision to reject the null hypothesis is correct. And the decision to reject the null hypothesis is incorrect. And then there's type 1 error, which is the probability of rejecting the null hypothesis that is true. Type 2 error, or also known as the beta error, is a probability of having the null hypothesis that is false. And then a type 3 error is possible with one-tailed test, where you would make the decision to rejecting the null hypothesis, but deciding to retain the null hypothesis because the reflection region was placed on the wrong tail.
Rejection.
What?
Rejection region.
Yeah,
Very well, as far as that.
yes.
Let me do it, so you know.
Alpha levels is the level significance of the hypothesis test. And then a non-directional test, or also known as a two-tailed test, are hypothesis tests in which the alternative hypothesis is stated as not equal to a value stated in the null hypothesis. And then a directional test or a one-tailed test are hypothesis tests in which the alternative hypothesis is stated as greater than or less than a value stated in the null hypothesis. And that is it.
Should I pick somebody or do you want to volunteer? Marina, you got it? Okay, cool. Awesome. Cool colors. Like this, like that. I'll try something really quick because I feel like some people ask me for Zoom and they're not on Zoom. So I'm just going to take this information. I'm going to send it through one more time in case anybody wants to join. Submit, and we'll just do. Oh, Emil successfully sent all course. Okay, so they know. All right, fair enough. Start.
Yeah, it's not the first time too.
Okay,
Yeah, I got it.
okay. Then somebody that was texting me earlier just wasn't able to make it. Okay, no problem. It happens. I'm just trying to be mindful. All right, walk us through it. We got here. Save away.
All right.
Chapter 5, probability allows us to make predictions regarding random events, random outcomes, and random variables. Probability is not useful for describing fixed events. The probability varies between 0 and 1 and is never negative. Hence, a specific outcome, it's either probable 0 less than p less or equal to 1, or improbable, which is p equals 0. Fixed event is any event in which the outcome observed is always the same. The sample space, also called the outcome space, is the total number of possible outcomes that can occur in a given random event. Two outcomes, A and B, are mutually exclusive when the two outcomes cannot occur together. The probability of two mutually exclusive outcomes occur together is 0. The adjective rule, yeah, okay, stated that when two outcomes for given events are mutually exclusive, the probability that any one of these outcomes occur is equal to the sum of their individual probabilities. And two outcomes like A and B are independent when the probability of one outcome does not affect the probability of the second outcome. And two outcomes, A and B, are complementary when sum of their probabilities is equal to 1. When the two outcomes are complementary, they are exhausted of all possible outcomes, so the two outcomes constitute 100 of the sample space. And then in each case, the variable of interest of the research is a random variable, in that variables can lead to any number of possible outcomes in a random experiment. In a random experiment, researchers are often interested in the probability distributed of a random variable, and the variance of a probability distribution is measure of variability for the average distance that outcomes for a given random variable. And a binomial probability is the distribution of probabilities for each outcome of a variance random variable. For chapter 6, the normal distribution is mathematically defined. The sum of a normal distribution is specified by an equation relation each score distributed along the x-axis, with each frequency distributed along the y-axis. So here's like the formula that we've been working on. 3 examples of a normal distribution with different means and standard deviation. The mean, the median, and the mode are all located in the 50th percentile. In a normal distribution, the mean, the median, and the mode are the same value at the center of the distribution. And I have like the right here. A z-score is a value on the x-axis of standard normal distribution. The standard normal transformation is a formula used to convert any normal distribution with any mean and any variance to a standard normal distribution with a mean equal to 0 and a standard deviation equal to 1. And again, this is the formula for the populational score or for a sample scores. Chapter 7, a sampling distribution is distribution of all sample means that could be obtained in a sample of given size from the sample population. Sampling with replacement is a method of sampling in which each participant or item selected is replaced before the next selection, and a sample design is a specific plan or protocol for how individuals will be selected or sampled from a population of interest. And the unbiased estimator, any sample statistics such as sample variance when we divide the SS by n-1 obtained from a randomly selected sample equals the value of its responsive population parameter. And a researcher selected a sample of, and this is an example, a researcher selected a sample of size 3 n equals 3 from a population of size 10 n equals 10 using the same example. How many possible samples of size 3 can be selected using the experimental sampling? And then like I have the formula right here. So it's basically to find the answer, we submitted the sample size n and population size n into the computation, and the total number of samples possible is as follows. So like right here, we have the 10, and then we just multiply 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. and then divided by like 3217654, 3 to 1 equals 120. Chapter 8, a hypothesis is a statement or a proposed explanation for an observation, a phenomenon, or a scientific problem that can be tested using the research method. Hypothesis testing is a method of testing a claim about a parameter in a population using data measured in a sample alpha, and is used to measure the error for a decision concerning true null and hypothesis. The alpha level is basically the same thing as the p-value, and beta is the measure of errors for decisions concerning false null hypothesis. And a type 2 error is the probability of incorrectly retaining the null hypothesis. A p-value is the probability of obtaining a sample outcome given that the value stated in the null hypothesis is true. And then, so here's some sample. The rejection region is the region beyond and critical values in the hypothesis test. So like just like the ends, like right here, rejection region. And then one-tailed tests are hypothesis tests in which the alternative hypothesis is stated as greater than or less than a value stated in the null hypothesis. So then this would be greater than, and then if it's like the tail it would end up in here is less than. And that's it.
Super, glad you're here. Awesome. Right. All right, who is brave enough? Ariel, you got it? Okay, cool. Awesome. Enable, Zoom, share. Do right here, share, play. And we are recording. Awesome, cool.
Okay, so I have my stats exam to review here. It is nothing special. Let me figure out how to, okay, there we go. There we go. Okay, so I have chapter 5 first. So probability, what it is, it's the frequency of times or outcomes that happen divided by the total of possible outcomes. And what you need to figure this out is the number of total possible outcomes, and there's a typo there, but how often the outcomes of interest occurs. And why you need it, you use it to predict any random event, but it's not needed in a fixed event since the outcome is always the same. So you need in random things, that's why you don't have it in a fixed set. And a note is that probabilities vary between 0 and 1. It can be decimal, fraction, percent, and it cannot be negative, which makes sense, right? Because when you're thinking about it, you're like, oh, the probability is 50%. You could say 50%, 0.5, or you could say 1/2. And all of that is between 0 and 1, if you think about it. Okay, so multiple outcomes. So there are 4 different kinds. There's mutually exclusive, which is where 2 outcomes cannot occur, and that's like flipping a coin. So it doesn't matter which one it is, like whether it's heads or tails. Independent is when the probability of one outcome does not affect the second outcome. So that's like if you were flipping a coin twice, or I was trying to look up examples online, and one of them was like having like a cat versus having an ant, and so I did 2 different animals here because it doesn't matter. They don't like, they're independent. They're not the same. So a dog and a lizard. And complementary is the sum of probabilities equal to 1. Outcomes exhaustive of all possible outcomes. So like that's like flipping a coin once, then again to see if you get a different result, or taking a test once and then taking it again to see if you get a different result, like we do in our unit exams. Conditional is the probability dependent on occurrence of outcome or changed by occurrence of outcome. That's like picking 2 spades out of a deck of 52 cards. Like what's the, like it's conditional because it's conditional to the deck of cards and the spades. I think if I'm incorrect, you can correct me on it. Next one, chapter 6 and standard deviation. The definition is a quantity calculated to indicate extent of deviation for a group as a whole. Number specifies distance from the mean, and we use it to summarize continuous data. Normally when continuous data is not significantly skewed or has outliers. You can see the little example there from Khan Academy. So that's the one is the sample for the, it's like the sample formula, and the other one's the population formula. And then Z-scores. Now I'm not going to be super great with chapter 6 because I wasn't here. I watched the things, but it's different. So if I get anything wrong, you can correct me. So Z-scores. The definition is to indicate how much a given score value differs from the standard deviation. So the number of standard deviation a given point lies above or below the mean. And we use the Z-scores to tell us about the value itself and where the value lies in the distribution. And that's a little formula there. I feel like we've done this a lot in class, like a lot. Chapter 7, so inferential statistics, because I didn't want to write statistics, so I just wrote stats. What it is it allows one to make predictions from the data being used. How we use it, you select a sample or a portion of data from a larger population, measure the sample statistic not interested in, like the mean or variance in the sample, to learn about the mean in the population. An example is an average ACT score for all 11th graders in the US, or and how that would be like related to household income, to test a hypothesis of like whether your scores are better if you live in a better community or vice versa. Now we have sampling distribution, and what it is, it's a probability distribution obtained through repeated sampling of a specific population, and it may use random selection of population to avoid biases and unbiased estimators. We talked about this in a different thing. I just thought it was interesting, so I put it in this point. And everyone in the population must have equal chance of being selected. So if like there's a square or like a box and there's 8 squares and you pick one, you can't replace the square when you're picking another one. You have to keep it now at 7, because then everyone gets a chance. It's not like the 8th person gets 2 chances. So an example is having a participant retake a poll multiple times of what kind of dog food they buy. That was kind of made off of an example I found in the book, and then one I found on like Khan Academy. And the formula is the standard deviation equals the standard deviation divided by the square root of the sample size, which, if you notice, is the same formula that we use for our standard error. And then we have chapter 8 and hypothesis testing. So what it is, it's a method for testing a hypothesis about a parameter or population, a systematic way to test ideas about a group or population. We also use this in like chemistry and stuff, but it's math. And why we use it to learn about characteristics of a given population, and then to determine the likelihood of that population parameter being true. And then the 4 like rules kind of are, you state the hypothesis, you set the criteria for the decision, you compute the test statistics, and then you make a decision. So if it's like, I was like, oh, I want to see if this test is like what's going to happen, I would state what I want, and then I would kind of set up how I want to do it, and then I'd compute the statistics, do the math, and then I'd make a decision on whether I thought it was like a true thing or not. And then we have one-tailed and two-tailed tests. So one-tail allows for possibility of an effect on one direction, and two-tail is possibility of an effect in two directions. So it's like you have your null and then you have less than or greater than. That's your one-tailed, and then your two-tailed, you have the null and it can be less or greater. And example of one-tailed was when we watched that video with the nonverbal autistic children. And they did that test towards the end where they were seeing if they either were getting the same results or if they were going to not get this, like do worse. So they weren't testing on whether they were doing better or worse. They were testing on whether they were doing the same or worse, which they didn't get any of them right because it was, the people doing the typing and not actually the children. And example of two-tailed, I don't know if I understood this correctly, but I thought of the one thing we did with Dr. Java back in like week 2, where we were seeing if the caffeine made the students do better or worse on the exam versus what they had done previously. And that would be a two-tailed because you're not just seeing if it's one direction, you're seeing if it's better or worse. And that's it.
Job. Back to the video. Absolutely right. Nice.
I don't put examples in it, I'm not gonna get it, so.
Didn't always have that video in my curriculum. I've added that one recently. So
It was a good video. It was a long video, but it was good. I don't know if my two-tailed example was correct or not, but
well, mean or less than that would make sense. Yeah. No, you nailed it. Knocked it out of the park. Yeah. Marina Ariel. Who wants to go next? Should I pick somebody? Andy, you got this? All right. Cool.
I'll figure it out.
Like your grit, Ariel.
What?
Like your grit.
Oh,
Grit. You know what that is, right?
I
That's
mean,
why you're doing, that's why you're, you got this. It's the grit. That's why you're able to do it. Let me, grit, G-R-I-T, yeah, grit. The determination, like you're going all these places, you're gonna figure it out.
Yeah, I mean, otherwise it's just not gonna stick, and then what then? I'm just gonna lose it all? No, I didn't know this stuff.
Yeah. All right, let's do the floor today. Any of you ready?
So. Is it not going?
It's not on my Apple, it's on the
Oh,
other
okay.
computer.
I did the same thing.
Okay, so probability. Probability is frequency. Oh yeah, I'm starting with chapter 5. It's frequency of times an outcome occurs divided by the total number of possible outcomes. And probability is used to predict any random event. So if there's a fixed outcome, you don't need to use probability. When you figure out probability, some stuff you gotta know is you need to know the number of total possible outcomes, also known as the sample space, and then how often something occurs. So the equation for probability is the f of x or whatever. That's the frequency of times a certain outcome occurs. And that's divided by the sample space. So here's an example. You got 300 high school students, 160 are male, 140 are female. So if you want to find the probability, you take, so the f of x, the 160 divided by the sample space, which is all the outcomes, that's turns out to be 53%. Things you should know when solving probability using the probability equation is probability varies between 0 and 1, and a probability can never be negative. So there's 4 kinds of relationships that can exist between 2 outcomes. They can be mutually exclusive, which is when 2 outcomes cannot occur together. Independent outcomes means when a probability of one outcome does not affect the probability of a second outcome. Complementary, which means the sum of the probabilities equal 1, or like, everything. And then there's conditional, which means a probability of an outcome is dependent on the occurrence of another outcome, or when the probability of the occurrence is changed by the, I don't know what I'm typing over here, but it's changed by another one, or a conditional relationship can exist if the probability of one event is given that another event occurred. I didn't know what Bayes' theorem was. I saw that in the thing. I don't know what Bayes' theorem is. I don't know. Does anybody know what that
Wednesday,
is?
Friday. Clearly what it stands for. I'll walk you through that.
I don't know.
I like the honesty.
No, I don't. I was
appreciate it.
pretty. Does anybody know what?
Anything else other than Wednesday, Thursday, Friday, right?
No, that's Wednesday, Thursday, Friday. Is
Or
Bayes'
what
theorem?
the-
When is it? I don't know. Do you guys know what Bayes' theorem is? I don't know what that is.
I'll walk you through it.
Okay.
I'll lecture to that after you
Yes,
or after you present it, guys.
And a random variable is a variable obtained in a random experiment. It's not the actual outcome of the experiment, but it describes possible outcomes in the experiment. An expected value, that's the mean or average expected outcome for a given random variable. Expected outcome is the sum of products for each random outcome multiplied by the probability of the occurrence. I don't know. I saw something about a bivariate random variable, and I was like, I don't know what that is. So
I'll lecture to that. too.
cool. Chapter 6. The normal distribution is called the symmetrical Gaussian or bell-shaped distribution and is a distribution where scores are symmetrically distributed above and below the mean, the median, and the mode at the center of the distribution. A z-score is on the x-axis of a normal distribution. The value of a z-score specifies the distance or the number of standard deviations that a value is above or below the mean. The standard normal distribution, or z-distribution, is a distribution with a mean equal to 0 and a standard deviation equal to 1. The standard normal distribution is distributed in the z-score units along the x-axis. The z-table is a type of probability distribution table displaying a list of z-scores and the corresponding probabilities associated with each z-score lister. We've used that thing a bunch of times. You guys know what that is. So to estimate probabilities under the normal curve, we determine the probability of a certain outcome in relation to all other outcomes. So there's 2 steps to this. First is transform a raw score into a z-score, and then step 2 is you locate the corresponding proportion of the z-score in the table. We were just talking about the z-score table. So here's an example. So you got a sample of scores that are normally distributed where the mean is 20 and the standard deviation is 2. And then you want to find the probability of obtaining a score greater than 24. So to find the z-score, you minus the probability or like of the score, you minus the score you're looking for, minus the mean, and then you divide that by the standard deviation, and you find the z-score. So for my example, I gave the example, the z-score is 2. And you look on the thing, you find out that there is a 2.28% chance of obtaining a score greater than 24 in this given example. Some more definitions. A sampling distribution is a distribution of all sample means or sample variances that could be obtained in distribution samples of a given size from the same population. Sampling without replacement is a method of sampling in which each item is selected is not replaced before the next selection. This method of sampling without replacement, is the most common method used in the behavioral sciences. Sampling with replacement is a method of sampling in which each item selected is replaced before the next selection. So sample design is a plan for how individuals will be selected or sampled from a population of interest. So a researcher who selects, so there's a population size of 11 and they select a sample size of 3. So using this sample example, they want to find how many possible samples of 3 can be selected from a population size of 11. So there's the equation. You got the equation. So in this specific example, if you want to find how many possible examples of 3 can be found in a population size of 11, what do you call the thing with like the exclamation mark where it does all of them,
So you have n, which is your population, and then the small n, which is the sample. So so when you say the size of 3, you're saying if I grab 3 out of 11, how many possible different ways can I do that?
Yeah.
And so that's where that comes from. So you start with your population total, and you multiply it by itself all the way down to 1, and then you divide it by the number of the sample all the way down to one, and then you multiply it times the difference between the population and the sample, all the way down to one.
Yeah.
So the small end is the sample, the large end is the population. The exclamation point is telling you, take what you have and multiply it all the way down to one, basically.
Yeah. So professor, he just explained it perfectly, and this is why he's the guy teaching it. I'm not teaching it. But you do this thing,
Oh, I'm
165.
gonna give you a WTF comment in a moment too.
Oh, okay, okay.
No, about me.
Oh,
This week, okay?
okay.
Anecdotally, and I'll wish for those things today.
So you do this 165 total number of samples can be obtained by taking 3 from 11, or however he said it. An unbiased estimator is a sample statistic, and it's like a sample variance when we divide sum of squares by n-1, and is obtained from a randomly selected sample that equals the value of its population parameter. The central limit theorem is what the central limit theorem means. Regardless of the distribution of scores in a population, the sampling distribution of sample means selected at random from that population will approach the shape of a normal distribution as the number of samples in the sampling distribution increases. So what the central limit theorem means is that at least 95% of all sample means we could select from a population are always within 2 standard deviations of the population. Stuff from chapter 8, it's a lot about hypothesis testing. So what hypothesis testing is a method for testing hypotheses about parameter population. 4 steps of hypothesis testing is you gotta 1, state the hypothesis, 2, set the criteria for the decision, 3, you compute the test statistic, and then 4, you make a decision. So there's 2 types of hypotheses, and that is the null hypothesis or the alternative hypothesis. The null hypothesis is stated as the null and is a statement about a population parameter, such as the population mean, that is assumed to be true. So the null hypothesis is the starting point when you're doing these tests. An alternative hypothesis is a statement that directly contradicts a null hypothesis by stating that the actual value of a population parameter is less than, greater than, or not equal to the value stated in the null hypothesis. So there's 2 kind of tests you can do. There's non-directional or 2-tailed tests, and they are hypothesis tests in which the alternative hypothesis is stated as not equal to a value stated in the null hypothesis. Researchers interested in any alternative to the null hypothesis. Directional tests, or 1-tailed, are hypothesis tests in which the alternative hypothesis is stated as greater than or less than a value stated in the null hypothesis. A researcher doing a directional test is interested in a specific alternative to the null hypothesis. Got types of errors. Type 1 error means you're rejecting the null hypothesis when it's true. A type 2 error is when you don't reject the null hypothesis when it's false. I didn't really know what type 3 error was.
I have notes and stuff like that.
Cool. Detect an effect. We did this sheet last week, I think, and some of the stuff we learned from that was a test with a larger population has a larger effect size. Actually, what does it mean for the effect
So the effect is like how much is happening with what you're looking at in terms of what you're trying to study. So if a small effect size is not much is happening with the sample, so you can't make as big of a generalization to the population. Medium, you can make a bigger generalization. Large effect size, you can pretty much almost say fact,
okay.
Not necessarily it's a fact, but you can believe it a lot stronger.
Yeah.
That help make.
Yeah. So in effect size is important in test because it kind of lets you know how reliable the test can be. So a test with a larger population has a larger effect size, so they have more power to detect an effect. A test with a larger sample has more power to detect an effect because it's more representative of the population. So that a test with a larger sample is more reliable. A test with a smaller deviation has more power to detect an effect because the smaller a standard deviation means it's closer to the mean. And then a test with a higher level of significance is more statistically significant, which means it gives it more power to detect an effect, which means it's more reliable. That's it.
I can explain that now or later, either way on, but we can definitely talk about it in class. I certainly appreciate the WTF because I was sharing earlier, there's this one semi-toxic Walmart University out here that keeps tracking how much my scoring of grades varies, and they're giving me crap about it every single year with different people, which is like WTF, like why don't you tell me how to grade? I had to yell at them after the first couple of years, quit sending me someone with a master's degree. It's kind of offensive. They had less training. I'm not being arrogant. Like send me someone with a PhD to give me a review. So yesterday, I yelled at them at WTF, like, why are you guys paying me a third of everybody else is paying for the exact same amount of work? And they really didn't have an answer. Clearly, it was Wednesday, Thursday, Friday. Couldn't mean possibly anything else. But I appreciate WTF on the stats. So I will either lecture that momentarily or after you all do your reviews, we'll jump right into that before we do any review worksheet stuff. But I can absolutely walk you through Bayes' theorem and bivariate variables. Or what the fuck, because apparently that's highly popular. I've been getting like positive student feedback the more I've been christened lately. So apparently it's like okay as long as it's not like talking like a sailor. Apparently it's like no big deal. So apparently that's like more your speed. Maybe because it's real. So and genuine. I was about to suggest that, yeah, actually. Take a quick break, and then we'll either come back to more reviews or bivariate variables, Bayes' theorem, and then the type 3 error. Those are the things that I will make sure to cover either between your stuff or right after that, and then we'll do the worksheet. That'll probably be the class. But yeah, you want to take 5 or 10?
Yeah.
Hudaifa, so glad you're here.
Not late at all.
Not late at all, but we're glad you were on break right now. So glad you're here though. Can you hear us? Hudaifa, glad you're here.
Oh yeah. Okay, yeah, there you go.
We're
Yeah,
coming back
sorry.
in 10 minutes. So if you need to do anything like that, usually makes you leave class, do it now.
Sorry for being late. I took a nap and I was like, I set a timer for half an hour. I was gonna wake up at 5:30, and then I was like, just 5 more minutes, and here I am waking up at 7. Sorry, it will happen again.
All right, glad you're here. No worries.
All right, I'm gonna go pray right now.
And then I gave you Zoom that you still showed up because we didn't start until about.
You were doing the Zoom.
Yeah, because we didn't actually start talking about stats about 6:20, 6:30-ish.
Oh, okay.
So we got not like derailed or anything. We were talking about a couple things, and then I was setting it up, and then I was telling a couple stories I didn't want to record, make her laugh. And I also walked in about 5 or 10 minutes late because I was walking over from the other building. So that's why. But I hadn't forgot about you, and then I sent it through twice because I was like, and then I saw you. But it was good for Hudaifa because he needed it. He didn't. Yeah. So
Somebody's returning that. I was gonna say.
if you need to go, you can stay on Zoom or you can watch the recording, whatever's good for you. I know you have family. I got you, Jack. Yeah.
It's not expensive.
It's okay. It's okay. So it's rote learning and repetition. Or what? I'll remember that like the rest of my life. Thank you for the humor. No, because it was honest and genuine. You really didn't know what it was. Like, I appreciate that.
I'm not gonna lie, I saw that too, like when I was looking through and I'm like, I'm not even gonna talk
Yeah,
about it.
I left it. I was like.
No, we can talk about it. We can dive
I
into it.
saw it,
No
I'm like,
problem.
I'm not going into depth on that right now.
I'm gonna have to check my notes, but I can absolutely walk. So Hudaifa, can you hear me? Oh, maybe you're still on break. Can you hear me? Or are you not back yet? trying to give you a full 10 minutes. It's been like 8.
Thank you.
Yeah. Mhm. We all have WTF moments. Happened to me this week. Started some more part-time. They're like, you can be full-time in 8 weeks. And they're like, nope, just kidding. So guess I'm not using your curriculum anymore. I'm using my curriculum. WTF. Just- And my tire blew up, so what the F. You wanna see a picture?
Yeah.
Oh, you know what? It's probably in the cloud.
How?
The mechanic didn't tighten the screws on the calipers and the brakes. So the brakes rubbed against the tire and then so I was driving on the freeway
On your car?
on my car and then I got off by Downers Grove. And then I was just sitting in traffic and suddenly the tire just. Probably, I think it's in my cloud. It's probably in my cloud. Seems so, doesn't it? Yeah, I'll show you. Think. Yep, here we go. Yeah. Yeah. Which wrecked my rim.
That happened today?
No, that happened like Saturday. I've had a Honda CRV all week. Kind of depressed. I got to return the car.
Why were you driving?
99 Jeep Grand Cherokee. But I'm thinking about getting something new soon.
Wait, Grand or Jeep?
Jeep Grand Cherokee,
So,
Laredo. So that was a fun Saturday. Good times. Glad I didn't have it on the freeway, or maybe you'd be going to my funeral and I wouldn't be teaching.
You don't like your Jeep?
I just don't like how unlucky it's been lately. Yes. But yeah, good times. What?
Okay.
It's a Laredo, Jeep Grand Cherokee Laredo, and it's rural drive, and it's got 381,000 miles in the car. Oh, it's a nice car. It's not real great on gas. I'm really glad that I'm not very pleased with the mechanic that did that to my car. To somebody's garage. Bad idea.
Yeah.
Works out of his house. Bad idea. I'll be Midas in the future. So good times. You? Oh, yeah, because I think I sent a picture of Hudaifa. Yep. Oh, now that you're back, my wife's in Canada or soon. She should be landing soon.
How
Yeah.
long was you there for?
Just a couple days.
I have a question.
What's your
Hello?
question? Yeah.
Uh,
What's your question?
When's the last time you traveled?
I think it was Mexico.
Like when? Oh, like the vacation you told us about?
I went to South Carolina to visit mom like a week later.
Oh, of course. Always traveling. Oh, always traveling.
So who's next to present? Why are you so suspicious, Hudaifa? Thank you, right?
Money launderer.
I'm not a money.
I wonder why.
Why, the class would like to know why you didn't come today. They're wondering who the real money launderer is, Hudaifa.
Yeah.
Hey, listen. No comment.
No comment. Oh, there we go.
As expected.
As expected, the plot thickens. All right. Oh, no. She was gonna go, but you asked me. That was my bad. I got you. No, it's fine. I'll stick with that. Absolutely. You can go first. That's fine. Did, oh, I need to refresh. Did you or did you, oh, you're right there. I got you right here. Come on. That'll absolutely work. Yeah, if it's like a PDF, it's totally, so what you do is you just go like present. And then you can do that, or we don't have to present if it's too small. Can everybody see that? Or we can go like,
And
you can go like
see-
that too.
Yeah,
Yeah, and then you just scroll and you can see everything. And why was it not sharing? Stop, share. Sure. Okay, cool. Yeah, perfect. Yep.
okay. So there's no colors. You can start. Okay, so chapter 5, simple probability is the calculation of an outcome or the chance of an event ever happening. It can be calculated by dividing the variable number of outcomes by the total number of possible outcomes. Probability is the relative frequency over an infinite number of trials. That's where I was trying to find the difference. And for example, that I have for that is probability, like when you flip a coin, heads or tail. You can always, it's either heads or tails. So that's why you only get half. You're not gonna get, more than that. It's 1, it'll go up to 1, right? 0, half, 1, exactly what I said. And then 4 types of relationships between multiple outcomes. I have mutually exclusive are events that cannot happen at the same time. Therefore, probability of having A and B at the same time is 0. And for independent, it's when the probability of one outcome does not affect the probability of this other outcome. For complementary, it's the event of one outcome happening and that the outcome not happening. So the sum of probability of an event and its complement is 1 or 100%. So conditional probability I have as that's where, let's say, A or B is the probability of an event occurring, given that event B occurs. So the example I have here is like the cards, I'll say. So let's say you drew a red card and the probability that it's a 4. So you'll have 4 and slash that red. So 2 out of the 26, and then you reduce it to being 1 out of 13. So it's given that red card, there are only 2 or 4, so it can only be 2 out of 26 or 1 over 13. The probability distribution for a random variable, possible values of the random variable X together with the probability of corresponding to those values. I'm not sure if I'm explaining this right, but that is what I kind of found as a shorter answer to explain what I was trying to get for the probability distribution part. For this
You're
part,
right, so we can jump into it. I think the workshop will help too,
yeah,
outside of the WTF that I've explained.
Okay.
Andy, which I will,
okay.
and or you will, depending on what you all have, but we'll address it either way.
Okay, and then for chapter 6, I have the normal distribution is a theoretical distribution, which includes the data that are symmetrically distributed around the mean, as well as the median and the mode. The 8 characteristics I have of a normal distribution is that normal distribution is mathematically defined. It is theoretical. The mean, median, and the mode are all located at the 50th percentile. The normal distribution is symmetrical. The mean can equal any value, and the standard deviation can equal any positive value. Total area under the normal curve is equal to 1. Tails of a normal distribution are asymptotic. I don't know if it's spelled right.
Asymptotic.
I can't see that word.
That means they don't touch the x-axis. That's a fancy way to say that. That's all that means.
Okay. The standard normal distribution is a special case
of the normal distribution with a mean equal to 0 and a standard deviation or variance equal to 1. I found this information, some of it from Quizlet to help me. I use Quizlet a lot. So also known as Z distribution, where values above mean have positive Z values and the values below mean have negative Z values. The normal approximation of the to the binomial is when you use a continuous distribution, the normal distribution to approximate a discrete distribution, the binomial distribution. So according to the central limit theorem, the sampling distribution of the sample means becomes approximately normal if the sample size is large enough. And for 7, the sampling distribution is the distribution of all possible values that can be assumed by some statistics computed from samples of the same size randomly drawn from the same population. Inferential statistics are techniques that allow us to use these samples to generalize about the population from which the samples were drawn. And for theoretical sampling strategy, I have is a sampling method in which we sample with replacement, and the order in which a participant is selected matters. So sampling with replacement is a method of sampling in which each participant or item selected is replaced before the next draw. Okay, so the 3 characteristics of sampling distribution of the sample mean, I have the sample mean is unbiased. On average, the sample mean we obtain in randomly selected sample will equal the value of the population mean. Distribution of sample mean follows the central limit theorem. So regardless of the shape of the distribution in a population, a distribution to sample mean selected at random from the population will approach the shape of our normal distribution as the number of samples in sampling distribution increases. As it increases. Okay, so a distribution of sample mean has a minimum variance. So the sampling distribution of the mean will vary minimally from the value of the population mean. And here I was trying to see, so to calculate the mean and standard error of a sampling distribution of the sample mean and to draw, I don't know if I got that. So the variance of the sampling distribution of sample means equal to the population variance divided by the sample size. And then the standard error of the mean is that the standard deviation of the sampling distribution of the sample means. So it is the square root of the variance. And then identify 3 characteristics. So sampling distribution, I say sample variance is unbiased estimator. I got this information from your PowerPoint. And then I said skewed distribution rule, and there's no minimum variance when you divide the SS by the DF. And then explain the relationship between standard error, the standard deviation, and sample size. As the population standard deviation increases, standard error increases. So hence, the farther scores in the population of deviate from the mean in the population, the further possible samples means can deviate from the value of the population mean. So as the sample size increases, the standard error decreases. And the more data you collect, the closer you estimate the value of the population mean. The relationship is explained by the law of the large numbers, I guess. For 8 hypothesis test, I have it as a statistical procedure used to evaluate on the basis of a sample and suppositions or expectations hypothesis about a population. The 4 steps of hypothesis, I have you state the hypothesis about the population, you set the criteria for the decision, you collect the data, compute and sample statistic, then transform the data results into a test statistic, and then you make your decision on the basis of your sample. You either accept it or reject your hypothesis at the end. I think that's where I couldn't get the other ones. It didn't save. I try to get, that's where mine ends.
Okay, that's fine.
Okay.
We're in. Oh, that's on the list anyways.
Yeah, thank you.
then you wanted to go, right, Nikki? Okay. Enable, Zoom, share. So it's this keyboard, this mouse, because everybody keeps grabbing the Apple. And then
Okay, got it. I missed like the last 3 weeks of class, so I might need to be corrected a lot. I've been like watching the videos and like reading the chapters and all the information I got from the notes I took and from the book. So here we go. So chapter 5 on probability. So the definition of probability is the frequency of times an outcome occurs divided by the total number of possible outcomes. So then there's the mouse. Can you see? So there's the equation there. Then there's 2 rules about probability. It can vary between 0 and 1, and it cannot be negative. So then there's different outcomes. We have mutually exclusive outcomes when the 2 occurrences can't occur together, and the probability of the 2 occurrence outcomes is 0 because I think flipping a coin is the common example, and then there's the equation for it. Independent outcome is when the probability of one outcome does not affect the probability of the second outcome. So then when the 2 outcomes are independent, the probability that both outcomes occur is equal to the product of their individual probabilities. And that's the multiplicative rule. So then that's the equation. So then you're multiplying by it. So correct me if I want, with the first one, it equals 0 because the probability with the second one, the probability of them both occurring or one of them occurring the second time, I forget the number for that one. I'm just a little confused on that one.
So you're never gonna exceed 100% probability. 'Cause it's
Right.
either gonna happen or not.
Mm-hmm.
So independent outcome, you multiply. Typically, multiplying is like or,
Mm-hmm.
and adding is like and in terms of outcomes.
Right.
So if you think, is it possible for this and that to happen, it's probability of A plus probability of B.
Mm-hmm.
If you get something like independent outcome, so you're looking at of them both occurring, you multiply them. And then, because that's really or
Right.
both of them occurring. So they both happen at the same time, multiply.
Mm-hmm.
If it's or multiply, if it's one or the other, or no, if you're adding, like if they can occur at the same time, they're independent. That's why you multiply. They can occur at the same time, and you have to add them together. Does that make sense?
Okay, I get it. Yes.
Okay.
Yes, because I guess I was confused between what occasions you add and when you multiply with them. So
I can go over that too, though.
that would be great. Yeah. So,
Go over that and then WTF. Gotcha. Which I think is all chapter 5. So I think if I lecture chapter 5 and then take questions or dive into it, you guys should all be good today.
that would be awesome.
What? One of them, the type of error is like chapter 8, I think.
Yeah, I was also confused about type 3 error. So
So I'll do chapter 5 and chapter error, which I think is either 7 or 8, but I'll pull it up, I'll get it.
okay. Complementary outcome is when the probabilities equal 1. So the probability of A plus B will equal
So
it
the
as a
coin
whole.
toss,
Right.
50% of heads or tails plus 50% of heads or tails
Mm-hmm.
is equal to 1, because you're not gonna have, they're both being 50%, they have to equal 1. You can't exceed it. You can't have greater than 100% possibility of anything.
Thank you. Conditional outcome. The little u always throws me off, and it means and, right?
That means and the other one.
And the upside down means or. Yeah, those just always throw me off. So it's when the probability of one outcome is dependent on the occurrence of the other outcome. So the outcome is dependent when the probability of this occurrence is changed by the occurrence of the other outcome. That sounds really confusing. I think I just typed that twice. Okay, so I think that I'm gonna try to explain it. So whatever the first outcome is, the second outcome will be different depending on what that first one is. So it's real, so,
Yeah.
yeah,
That's right. 'cause
Okay.
It influences it.
yeah,
So like a real world application, if you want to like have some sink your teeth into, if you get the interview, you have a greater probability, you have a probability of getting the job or not getting the job.
mm-hmm,
But the interview still drives the probability of that outcome.
mm-hmm.
Those two different things happen.
Oh, Bayes' theorem. A mathematical formula that relates the conditional and marginal or the unconditional probabilities of the two conditional outcomes that occur at random. I also was really confused about this. I know, yeah, I was really confused about this one as well, but I threw it in there because it was part of chapter 5.
So it's adding all the probabilities of both the conditional where one influences the other
Mhm.
and accounting for when one does not influence the other, which is your unconditional probability. And that's the formula to do it. And I think I have an example on my slides where I can walk through that too.
Mhm. Okay, yeah.
But you're
Chapter-
basically, you're accounting for both types of probabilities and you're multiplying them together. So the probability of A and B is the probability of B divided by A times the probability of A divided by the probability of B. So what we're looking at is how do we know the probability of both the conditional where one influences the other or the one where they're like independent? That's what Bayes' theorem is, it's accounting for both. You
Okay.
probably won't, it's usually independent, conditional, mutually exclusive, and I might try to think, if I go back, there's 4. Go back. Independent, mutually exclusive, and independent, complementary.
Complementary.
So when one influences, so when they're together,
Mhm.
so it could be conditional, complementary, independent, and mutually exclusive. Bayes' theorem accounts for all of those because conditional, unconditional possibilities mean all those possibilities.
Mhm.
That's what it is. You wouldn't use it a lot unless that you were trying to figure out like a list of probabilities for like an event or something of things happening. Then you might use that, but usually you just stick to the basic formula. And I can dive into that more than all day. That's probably a little clearer to you just say that, hopefully. It is. Okay.
Yeah. Okay. Chapter 5 was definitely my worst. So like
Yeah.
hopefully it just goes a little faster from here. But chapter 6. All right, so we're gonna talk about normal distributions and z-scores. Oh no, you can't see the word. It's okay.
You can't see what?
There, right here, you can see I have it's cutting off. I think I'll read the sentence and I'm sure I'll remember what the word was. It's a theoretical distribution in which the scores are symmetrically distributed above and below the mean, median, and mode are at the center of the, what do you call that line?
Mean.
The
Central distribution, central tendency.
this line, that line, what is that called? That line in the middle. I don't know what that's called.
That's your central tendency.
Yes, on the center of the tendency. Or
Center of the, it's tendency, center of the tendency, because
Yeah.
they're on top of each other. And then if they're not on top of each other, that skew makes it skewed one way or the other.
Right.
So that's central tendency, yeah.
Okay, so my picture covered the last word, but yeah, it's been the mean, median, and mode are all lined up, so then it's even on both sides. There's 8 characteristics of them, and I try to put in little either equations or something to help to describe it. So the first one is it's mathematically defined, and I liked this one because it kind of, I love labeling things in an equation to give what they mean. Not that we'll really use this equation, but that's how you define it. It's theoretical, which means that although in theory it'll turn out like this, it's usually things don't always align perfectly. So in real life, the mean, the median, the mode are located at the 50th percentile, so in the middle. It's symmetrical, so if you fold it in half, it'd be the same on both sides. The mean can equal any value, so it's infinity in both directions. The standard deviation can equal any positive value. So anything greater than 0. The total area under the curve of a normal distribution is equal to 1. So then the portions of it vary between 0 and 1, which is makes sense when we're talking about probability. It varies between 0 and 1. The tails of a normal distribution are, oh man, this word,
Asymptotic.
asymptotic. Well, it means that it's always going towards the x-axis, but it never actually touches it. So it's just going in, that's, which makes sense if we're talking, if the mean can equal any value and it's going on into infinity, then it would make sense that the tails are always going towards x but never reach it. Then we talk about z-scores, which is the value on the x-axis of a standard normal distribution. So the number is going to specify the distance or the number of standard deviations that a value is above or below the mean. So then z distribution is a normal distribution with a mean equal to 0 and a standard deviation equal to 1. The standard normal distribution is distributed in z-scores along the x-axis, right? So if we have the mean, median, mode all lined up in 0, you're going to go like in increments towards 1, negative on one's negative if you're looking this way, positive that way. So this is there's like a lot of different pictures I was looking at, but this one I like this one because it just kind of shows, instead of it just being like 1, 2, 3, 4, it's the number is starting here in the center, 0, and it's going positive in one direction and negative in the other. Chapter 7, we're talking about sampling distribution. So it's a distribution of all sample means or sample variances that could be obtained in samples of a given size from the same population. You can see the we got that, or even on both sides. When the two occurrences, so we have mutually exclusive outcomes. So when the two occurrences can't occur together, yes, then the probability of them occurring together is 0. I think we use this for behavioral research. So then there was an example in the book that I really liked that was helpful, where it said there was like 8 cards down and there was 2 of each number or letter. So they were like, so let's say that you're selecting 1 out of the cards, you're trying to select card labeled A and there's 2 of them. So you'd have 2 out of 8 chance of selecting it. And then if you didn't put that card back and you were trying to select an A again, it's 1 out of 7 now because one of the cards has been gone. So then it changes the probability of it being drawn a second time. So that's example of sampling without replacement. This is sampling with replacement. And so this is where the item is put back, and this is used more for statistical theory. Sample design or theory. So it's a specific plan or protocol for how individuals will be selected or sampled from a population of interest. And so then there's, correct me if I'm wrong, there's 2 sample designs, which are theoretical and experimental, which just depends on how we want to find out the total numbers if possible. So in the theory, statistical theory, you're taking the number of the population and then you're raising it by the sample number of the sample. Yes, or did I switch that? The n, so n raised to the little
N
n.
power, yeah, because it's n
Yes.
exclamation point.
Well, there's
divided
2.
by-
There's this one.
That's your, we're gonna use the experimental one the most.
Okay.
The theoretical is the n to the n power, so it would be the population to the sample power of
Yeah.
your theoretical. We use this one way more though, the
Right.
experimental, because it's more like applicable, like
Yeah.
there's more applications of it.
Yeah, so with the experimental, a question with that, is there like an easier way to calculate it than like just typing, like, I don't know if it's like 11 times 10 times 9, like, is there an exclamation point button on calculators that I'm missing?
I don't think there is.
That's like so annoying. I feel like there should be. Anyway,
You don't have a TI in class?
I
An
do.
Exclamation point anywhere on that?
I have one, but I did not find one.
I think there is.
All right. I just thought I'd ask. Maybe someone was doing it like a lot faster than me.
You should invent that. You should invent that. Somebody should.
All right, and then chapter 8. This one I was also a little shaky on because I like I like the slides and we were doing the worksheet and then I didn't feel good, so I left class early, so. I'll try my best. Okay, cool.
Unless that's all you have.
Oh, no, I have slides, I promise.
Okay.
I mean, I did web assign stuff, so like I have like somewhat of an idea. It's just not always easy to explain it.
Okay.
So hypothesis, I'm starting there, and it's the statement or proposed explanation for an observation or phenomenon or scientific problem that can be tested. And it's usually a statement about the value for a parameter in the population. So then the hypothesis testing is a method for testing a claim or hypothesis about the parameter in a population using data measured in a sample. And so in this method, we'll test a hypothesis by determining the likelihood that a sample statistic would be selected if the hypothesis regarding the population parameter were true. So that's a lot of words. Basically, we're just trying to figure out if what we're guessing from our observation would actually occur. So then there's steps, and the first one is to identify a hypothesis or claim. And usually it's something you'd think should be tested. Just not going to come up with anything. Usually has to do with some kind of observation. Then you would select a criterion which you would decide if the hypotheses are true or not. So I think that's like when you're trying to test something, you're trying to find samples of it. And if you can't even find anything close to that, then you might just say, I'm going to reject the hypothesis at this point.
So what you're usually doing is you find we're finding rejection regions.
Mm-hmm.
So basically what it is, it's either if it's before this rejection region, you retain the null hypothesis. If it's at or beyond, you reject it. I looked that up because you probably like a long time ago, like you want to think, oh, if it's right at the spot, you still retain. No, it's actually if it's right on the line and beyond, you reject.
Okay. So then after you do step 2, then you would select a random sample from the population and measure the sample mean. And then you would compare what you observed in the sample to what you would expect to observe if the claim you're testing is true. So you're going to say, this is what we were expecting to see. Did what actually happened when we tested it line up with that? So then there's the types of error, and I have a little, this might even be more helpful, a little.
Talk about that with us because that's a really good chart. That's correct. Yeah,
Okay.
that's correct.
So the thing that like confuses me. Okay. I guess I kind of understand it. So you're saying, so if you're rejecting the null hypothesis, a type 1 error is if it was supposed to be, it was actually true and you rejected it.
So it's a false positive. So it actually should have been.
Or it should have been. See, that's what I don't understand. The rejected and the not rejected.
So you actually, so it's a false positive to reject it, you actually, and that is, so the null hypothesis is rejected, which means you would retain or accept the alternative hypothesis. So you made a mistake as a false positive. You actually should have you actually should have rejected the alternative hypothesis rather than rejected the null hypothesis, which makes a type 1 error. The false, rejected, correct decision, true, positive. So in this case, you rejected the null hypothesis and you made the right decision, but that's not an error. So the type 1 and 2 errors have to do with making the wrong decision in your hypothesis acceptance, whether we're talking about a null or alternative hypothesis. So this is null hypothesis, false positive. We should not have rejected it, but we did. That's why it's type 1 error. The correct decision would be the true, hypothesis is no error. Same thing with the true, not rejected, correct decision, true, negative. Because we didn't reject it, so we would have retained the null hypothesis. We didn't reject it. That's the right decision. Type 2 error, not rejected, which means we would have retained it for the null hypothesis. It was type 2 error because it was a false negative.
Gotcha. Okay.
So it's saying like we made the wrong decision because we did something incorrectly in our calculation.
Right.
That's what those 2 errors are, and we'll address the type 3 error, the WTF.
It just confused me because it would say like it's rejected and it'd say like false positive. So like when you think of rejected, you're not thinking positive. So I think the wording was
The false positive is that like your decision to reject was wrong,
Mhm.
that's the type 1 error, that's the false positive.
Got it. Okay.
And then it's the same thing on the not rejected. Your decision to not reject the null hypothesis was a false negative,
Mhm.
and you should have retained it.
Yeah.
No, the not rejected means retained, so you should have rejected it, and then it would have been,
Mhm.
like, does that make sense?
Yeah, it makes sense. I think just the wording in the
wording's
graph,
a little off.
it's
These are math
confusing.
people that they maybe could have wrote that better, yeah.
but I mean, it makes sense. It's just the way it was worded is confusing. I think that was.
Yeah, not with at 3. We'll talk about that in a little bit.
Oh, I understood.
Okay,
Okay, I guess I do have a question. If we could address just these, the alpha and the beta, or I think it's beta, maybe, I don't know. I should know this, I'm Greek. The symbols that they're
that's
using.
beta, that
It
was
is-
alpha.
I'm so glad.
That's totally correct.
I guess I'm just asking what do they symbolize? Or like what, like are they used in mathematical terms? And like are they used in equations?
They're used in terms, so the alpha level has to do with the statistical significance. So if the alpha level is like 0.2, then we're use an 80%. Like statistical significance, which is the bare minimum for social sciences. So a lot of times the alpha was 0.05, which meant we were doing probability is 0.095. So the alpha is plus the probability always equals 100%.
Mhm. Okay. All right, that makes sense. Thank you. Okay. Unless, did you want to say something else?
No, I'm gonna walk you guys through the beat. I'm not sure. We'll address that too in a moment.
Okay. So then the two-tailed test, I didn't put one-tailed in there for whatever reason, but I guess I forgot. So it's hypothesis test in which the alternative hypothesis is stated as not equal to a value stated in the null. So then any other value besides the null hypothesis is of interest. So if it's above the null or below, as long as it's not equal to, it's of interest to the results. The critical value is the cutoff value that defines the boundaries beyond which less than 5% of the sample means can be obtained if the null hypothesis is not true. So samples beyond the critical value result in a decision to reject the null hypothesis. So if it's going beyond a certain boundary, then it's just automatically like, this is the
Yeah, if it's
probability.
inside to retain it, it was outside to reject the null hypothesis.
Because the probability of it's just too small of a percentage.
Yeah, because what we're talking about is we're looking at where it falls in relation to the mean. So we're basically saying, okay, so the region of where it's gonna fall close to the mean to retain our null hypothesis is sort of under that bell curve. And I'd be skeptical if it actually was right on a dot. I would be skeptical in terms of what you know what is for their test at that point. But if it's right at it and beyond, then you're typically gonna reject it. But generally, when we do the math, it's usually beyond enough that you know, or inside of enough that you know that you retain. So either retain inside the critical regions or reject outside the critical region. The critical value is that point we're looking up in the Z table in terms of where it is on the curve that tells what we're doing. And then the two-tailed is you're not sure there's something going on, and the one-tailed is to the left or the right, usually
Right.
less than or greater than typically is when you know what tail test to use.
Okay. More, you guys. Rejection region. Oh, I think we just kind of talked about that.
Yeah.
It's the same thing.
If it's
It's a little
basically,
redundant.
it shouldn't match it. If it matches exactly or it was beyond, reject. If it's below, retain.
Okay, and the statistic.
Statistic.
I'd
So
lo-
we're converting that, the Z statistic is basically changing a score into a standard deviation
Mhm.
by plugging in the X value. And then the Z obtained value is comparing it against the Z statistic, and that's what tells you if you reject or retain the null hypothesis. And the formulas are very similar, and I can write those up on the board if you don't like to, no problem at all.
Okay. This is apparently a joint presentation. Thank you.
That's
Jen.
fine.
Alright.
Build a community.
I actually understand it like way more now that I like presented that.
So the whole point is we review, we figure out what the questions are, and then hopefully when you all get to the test, it's not brand new and you're not stuck. Like,
We have a guy or two left and like one, who else? Who would like to go next? Esther? Okay, yeah. 100% fine. No, Hudaif is totally spaced out, so he's not presenting.
Oh.
Yeah.
5 points off.
Something.
Is yours blue?
So if we go Zoom, and then we could go present. Yeah, we can go present, and then you can just, yeah, this or this.
remember, it's not the Apple. I know everyone wants to use the laptop, but it's the
Chapter 5 through 8. Chapter 5 is probability. So the probability is the frequency of times outcome occurs divided by the total number of possible outcomes. And then the symbol is a tiny p. Probability can be used to predict any random event or an unnecessary fixed event. Calculating probability. In order to calculate probability, we need to know the number of possible outcomes we can get. So the equation for probability is the px equals fx divided by sample space. To compute the probability, we must follow 2 steps, which is find the sample space and then find the x. How to verify when solving probability equation. The probability varies between 0 and 1. It can be written as a fraction, decimal, percent, or proportion. It is more probable when closer to 1, and then it is more improbable when closer to 0, but probability can never be a negative. Relative frequencies, it's distribute frequencies, which have sample space, the sum of frequencies in the denominator, and then distribute relative frequencies reflect the outcome for each probability distribution. There's 4 multiple outcomes, which is mutually exclusive, independent, complementary, and conditional. So mutually exclusive is the 2 outcomes can't occur together. So if we were to flip a coin, then it's not possible to flip both a head and a tail at the same time. Independent, when the probability of one outcome doesn't affect the probability of the second outcome. So like flipping the coin twice. Complementary is the sum of probabilities equal to 1. So flipping the coin 1 time and the probability of flipping a head or tail equals 1. Conditional is the probability of occurrence changed by the occurrence of or outcome. So when wanting to determine the probability of drawing the 2 heart cards from the deck, so that was on the PowerPoint for the example. Bayes theorem. Bayes theorem formula relates conditional marginal probabilities of 2 conditional outcomes occurring at random. Probability distributions, the random variable, a variable obtained or measured in a random experiment. Distribution of probabilities for each outcome of random variable. So each probability and distribution ratio. Oh my God. Distribution ranges from 0 to 1 and is never negative. And then the sum of probabilities and distribution for random variable, which is x is equal to 1. And then variance and standard deviation of probability distributions. So to compute it, variance. Oh, so the variance of probability, that's the equation for the variance of probability distribution. And then that's the equation for standard deviation. Expected value binomial distribution. Distribution of probabilities for each outcome of bivariate random variable. There's only 2 possible outcomes, so it can occur by natural occurrence or it can occur by manipulation. Chapter 6 is probability, normal distributions, and z-scores. Normal distribution, the theoretical distribution is the data that is symmetrically distributed around mean, median, and mode. Scores that are closer to the mean are more probable than scores that are further from the mean. The behavioral data that researchers measure tend to approximate normal distribution. So the characteristics of normal distribution is normal distribution mathematically defined. So the shape of normal distribution is specified by an equation relating each score with each frequency. The normal distribution theoretical is behavioral data typically approximates the normal distribution. The mean median mode is located at 50th percentile. The normal distribution symmetrical is above mean, exactly same as below mean. I was confused with the folding test, the fold distribution in half. And then
It's symmetrical.
oh, so just a line.
This is the fold.
Okay.
That's
I
all it
see.
is. The fold.
Okay. So then mean can equal any value. It can equal from positive infinity to negative infinity. And then the standard deviation can equal any positive value. So the data can vary from the standard deviation greater than 0 or not, or it can't vary at all. So it's the standard deviation equals 0. And then the total area under curve equal to 1. So it can never be negative, and the proportions of area used to determine the probabilities. And then the tails of normal distribution asymptotic.
Asymptotic.
Okay.
Asymptotic, so it's like, you want to say like almost like the word symptom, asymptotic, and it just means that it doesn't approach the x-axis.
Okay, yeah, because it never touches. Z-score and standard deviation. So the standard normal distribution, so is mean equals to 0 and the standard deviation is equal to 1. So in the x-axis, it is distributed in the z-score units. Z-score, it's the value on the x-axis. The standard deviation is the number that specifies the distance from the mean. And then standard normal transformation, it is a formula used to convert any normal distribution to standard normal distribution with a mean of 0 and standard deviation of 1. So those are the equations for population of scores and sample of scores. And then you can use transformation to locate where the score would fall in standard normal distribution. The unit normal table, so the probability distribution table, list of z-scores corresponding probabilities, so proportions and associated with each z-score. And then the unit normal table has 3 columns, which are the ABC. So it's what we've been using. So the first column is it only lists the positive z-scores. And then column B lists the area between z-score. So as the z-score increases, it moves away from the mean. And then the column C lists the areas from the z-score towards tail. So as the z-score increases, the area between score tail decreases closer to 0. Locating proportions, area at each z-score given as proportions. So we use the unit normal table. Z-score, locate proportion or probability for score. So to locate proportion, you have to transform the raw score, which is X, into z-score. And then you locate corresponding proportions for z-score in a unit normal table. And then you sketch to make a certain, to understand like the negative and positive areas. And then locating the scores. The unit normal table can be used to locate the scores that fall within the given proportion or the percentile. To locate the score, we need to locate the z-scores associated with the given proportion in the unit normal table. And then we transform the z-score into a raw score, which is the X. And then you do the z times standard deviation plus the mean. And then chapter 7 is probability and sampling distributions. So the random selection is to avoid bias. All individuals in the population must have an equal chance of being selected. It is a common source of error. The probability of selecting each participant must be the same. Sampling distributions, it is a distribution of all possible samples, means or variance. It can compare statistics obtained in samples to hypothetical populations like the mean and variance. Sampling without replacement is each participant selected, not replaced before the next selection. So
I did the example from the PowerPoint, just changes the numbers. So it's like place 88 squares on the desk. So we'll say 7 are marked A, 7 are marked B, 7 are marked C, and 7 are marked D. The probability of selecting square marked A, so then we do the 7 divided by 28 equals 0.25. And then sampling with replacement, the participants for each selection is the same. It is typically not necessary in behavioral research. So for example, the population of 100 women, so 1 divided by 100 is 0.01. And then selecting sample, so sample design, it is a specific plan or protocol for how individuals will be selected or sampled. It must answer the 2 questions. So does it matter, or is it sampling with or without replacement? And then there's 2 strategies for sampling, so theoretical and experimental. And then the theoretical sampling is the order matters in sampling with replacement. So the formula is the N, and is that like the N squared type of thing?
Yeah, theoretical is the sample, is the population to the sample size, that's your exponent. So you're multiplying it times that many times, like times itself. So it'd be, so that was 3, the capital N times capital N and capital N theoretically. And then the experimental is when you subtract the amount of the sample size you're trying to get, and then you do N all the way down to 1, and then you do small n times the difference between the 2 for the experimental. So we use experimental way more, but that's the right formula for theoretical.
Yeah, because it was driving me crazy when I was trying to do the squared. So I just did 7 times 7, 49 samples. Experimental sampling, the order does not matter, and sampling without replacement is it's the most commonly used one in behavioral research. The formula can determine number of samples of any size that can be selected from population. So the population is 3 people, samples possible is 2. So sample distributions, mean. There are 3 ways sample mean is related to population mean. So it's the unbiased estimators, central limit theorem, and minimum variance. So the unbiased estimator is randomly selected. Sample equals value of population parameter on average. The central limit theorem is the shape of sampling distributions of sample means that tend toward normal distribution. And then the minimum variance is the variance of sampling distributions of sample means minimal. And then chapter 8 is the hypothesis testing, significance, effect size, and power. Hypothesis testing is a method for testing hypotheses about parameter or population. The purpose of it is to test claims or ideas. The goal is to determine the likelihood that population parameter is true. A hypothesis is a statement that explains an observation for a problem that can be tested using a research method. The null hypothesis is the population mean that is assumed to be true. The alternative hypothesis contradicts the null hypothesis by the actual value of population with less than, greater than, or not equal to. And then there are 4 steps to hypothesis testing. So step 1 would be state the null and alternative hypothesis. Step 2 would be set critical level. Step 3 would compute test statistics. Step 4 is make the decision. So in order to locate the probability of obtaining sample mean in sampling distribution, we need to know the population mean and the standard error of mean. And then when we retain or reject the null, there's only 4 possible outcomes. So the decision to retain the null is correct. The decision to retain the null is incorrect. So that's a type 2 error. The decision to reject the null is correct. And then 4 is the decision to reject the null is incorrect, which would be the type 1 error. And then the type 1 error is the probability of rejecting a null that is true. Type 2 error is the probability of having a null that is false. Type 3 errors retain null because rejection region was located in the wrong
tail.
Wrong tail.
That's when it's, so you looked at it wrong. So you looked at this tail, you should look at that tail, it's your type 3. or vice versa. That's all that type 3 error is. So we've covered some, but I'll still do all the WTF stuff. But I think we've got like 2, 3 of them knocked out so far. But I will cover whatever we don't get to with your reviews. But when I saw it, I wanted to draw it so it would like for everybody. Doing awesome. Keep going. Yeah.
Okay. Alpha is the level of significance of hypothesis tests. And then the power is the probability of rejecting false null hypothesis. And then the alpha is considered more like determined, and the type 1 error. The beta is the type 2 error. And then the power avoids type 2 error.
I don't think-
Well, it's not an error equals truth.
I'm not trying to talk over you.
Oh, no,
I'm
no,
just trying to-
no, you're good.
If they had a question and I see you present it, I'm like, does that make sense to you?
Yeah.
Should I explain more? That's all.
Effect and effect size. Effect is the difference between sample and population mean stated in the null hypothesis. It is significant when the null is rejected and insignificant when the null is retained. Effect size is the percentage of variance explained by a variable, and it is the most meaningfully reported with significant effects. That's it.
Oh, yeah.
Is left here. Lewis or Hector, who wants to go? You want to go? Okay, cool. I think you're further. No, you're right here. Perfect. Presentation. Open that. Zoom, share. Is this helping you, Daifa? Is it making sense? You can just give me a thumbs up. You don't have to use your mic, or you can, either way.
Yeah, it's getting better. I feel like this review is better than the first one for me, at least.
Okay, cool. Okay, cool. There you go. And remember, you're on this computer, not that one. Remember.
Cool. Walk through.
All right, first for chapter 5, probability. Probability is the frequency of times outcome divided by total number of possible outcome. This is a random event. The formula is fx divided by sample space. Relative frequency is the probability of occurrence. For relationships can exist, one mutually excessive cannot occur together. This includes the additive rule, the probability of any outcomes occurring equal to some. Independent outcome, probability of one does not affect another. The multiplicative rule is the probability of both outcomes equals product of individual. Complementary outcome, the sum of probabilities equal to 1. And then for conditional outcome, probability of one outcome is dependent on another. Probability of one event A given another occurs B. Chapter 6, probability, normal distribution, and C-scores. A C-score is a value on the x-axis of a standard normal distribution. The numerical value of a C-score specifies the distance of standard deviations that a value is above or below the mean. The standard normal distribution / C distribution is a normal distribution with a mean equal to 0 and a standard deviation equal to 1. Formula for C transformation is Z equals X minus M divided by standard deviation. For chapter 7, probability and sampling distribution, inferential statistics select a sample of data infers about a population means, measures mean variance in sample and the random selection of what biases. Theoretical sampling is order matter in sampling with replacement and over the power n where n equals population and n equals samples. The experimental sampling formula, that one right there, this determines the number of samples of any size that can be selected from population. And for chapter 8, the hypothesis testing, a null hypothesis is assumed to be true. The alternative hypothesis contradicts the null hypothesis. The rejection region is the region beyond a critical value in a hypothesis test. Compare the Z obtained score with the alpha score and see if it exceeds the boundaries. And then I just need verification with chapter 5's Bayes theorem, variance of probability distribution and the standard deviation of probability distribution. And for chapter 8, I kind of got the differences when they were presenting. So non-directional is the two ties, which is the two different rejection regions. and directional is just the one.
Basically like less than or like greater than.
Yeah. That's it.
Now, some of this may cover the worksheet, but.
Through it, we got Hector, right? Or it's homework, yeah. It's a review worksheet, so you do all the test. That's what's up with that. I mean, I guess on his homework and you could just hope for the best. I can tell you where the YouTube video is on it, but if we do it as a class, and I talk about any of the other confusing stuff, and that's the remainder of our time spent together, there's a pretty good chance you're gonna do well in the test. I'm trying to stack the odds in your favor. When you get to the test, I can't help you. I mean, I don't know what type of goals you set. I hope they're realistic ones. It's always important to set them. It's usually better if they're realistic. But I guess they don't have to be, Andy, but it's better if they are. I like the background. All right. Walk us through it, Hector.
The exam 2 review, chapters 5 to 8. Probability is used to predict an outcome. Good to know what a random event and a fixed event is. Random event is any event in which the outcome observed can vary. For example, the toss of a coin or lottery draws are random events since the outcome is random. Did I say that right? Yeah. Fixed event is any event in which the outcome observed is always the same. Sample space, also called the outcome space, is the total number of possible outcomes that can occur in a given random event. When flipping 2 coins, there are 4 different possible outcomes, so the sample space is 4. Probabilities varies between 0 and 1. Probability can never be 0. Mutually exclusive is when 2 outcomes cannot occur together. For example, the outcome of getting passing grade or not is mutually exclusive because you're either getting a passing grade or you're not. You can't get both. The probability for an outcome is independent when it has no effect on the next outcome. Chapter 6, normal distribution, also called the symmetrical Gaussian or bell-shaped distribution, is a theoretical distribution in which scores are symmetrically distributed above and below median and mean and mode at the center of the distribution. This is what I thought it was, since it's like right here in the very center, and they're equal on each side, which would be this one. These other 2 ones are not what there's are not the normal distribution. This Z-score is a value on the x-axis of a standard normal distribution. The value of a z-score specifies the distance or the number of standard deviations that a value is above or below the mean. Standard normal distribution or Z distribution is a normal distribution with a mean equal to 0 and a standard deviation equal to 1. Formula for Z transformation is something you want to know, but I couldn't get that down. I couldn't copy it because they're symbols I couldn't paste on. And area at each Z-score is a given proportion. Sampling distribution is a distribution of all sample means or sample variances that could be obtained in samples of a given size from the same population. Sampling without replacement is a method of sampling in which each participant or item selected is not replaced before the next selection. Sampling with replacement is a method of sampling in which each participant or item selected is replaced before the next selection. These 3 I really don't understand, so I just wrote the definition now.
Okay. Just make sure that we. go back to that.
Oh.
Now, or?
Oh yeah, whenever. It does.
Okay.
An unbiased estimator, a sample mean when
the sample mean we obtain randomly, any randomly selected sample equals the value of the population mean on average. Central limit theorem, when the probability distribution for obtaining a sample mean from population is normal. Standard error is the standard deviation of a sampling distribution of sample means. Sample error is the extent to which sample means selected from the same population differ from one another. Law of large numbers states that increasing the number of observations or samples in a study will decrease the standard error. Null and alternative hypothesis. Null is statement about population parameter assumed true. Alternative hypothesis, statement that contradicts the null hypothesis. Statistical significance describes a decision made concerning a value stated in null hypothesis. When the null is rejected or not, the significance will either be reached or be considered failed. P-value is the probability of obtaining a sample outcome. Type 2 error is the probability of retaining null hypothesis when it is false. Type 1 is the null hypothesis is rejected when it is true.
Back to sampling. So it was these two, right? The last two, or was it all of this slide? So sampling distribution, like how, like, I mean, the best was probably to. Sorry, Diana, you can't see this, but it's all right. You can just listen.
I can see the screen, so it's fine.
So like in deck of cards, like the distribution of all the sample means or sample variances that could be obtained in a given size from the sample population. So like like whatever I select from the cards or the sample means, like it's like kind of like everything. Sampling without replacement is I take, and I can give you some more context on that too in a moment. But like sampling without replacement is I grab this card, 6 of hearts. Now so that I had a 1 in 52 possibility if I was trying to pick this. Now I have a 1 in 51 sampling without replacement. Sampling with replacement, I put it back in there, and now it stays the same. Does that help at all with the cards a little bit or no? Yeah, so sampling distribution, that's all sample means or sample variances that can be obtained in the size of the same population. I think I can probably show you an example on another slide, but these last two, sampling without replacement, that has to do with like, I have what, 13 of each suit, right? And I have 52 cards in total. So if I wanted to say, what's the possibility of selecting hearts, what? Or hearts, it'd be 13 out of 52. So if I grab hearts, of course it's clubs. So if I grab one of the hearts, now it's 12 out of 52 sampling without replacement. If I put it back in there, sampling with replacement, it's the same amount of possibility because I replaced the sample. So it'd be 13 out of 52. Because those last two at least clearer. Okay, I'm gonna come back to the sampling distribution. Okay, so then you type 3 error. We went over that. That makes sense. Okay, and then what was the other one? What the F is a? I can look at your presentation too. Bayes theorem, which I think is in chapter 5. So let me pull my information up, and then I'll do some chapter 7. I think it's in chapter 5 also. Yeah, so I'm gonna try to just find that, show that to you guys, and then maybe try to like give you like some examples and like really dive into it. And then we'll look at the chapter 7, and then if there was any chapter 8 stuff, I think chapter 6 you all like had, like that seemed to be pretty consistent across the board. Enable, Zoom, share, play. Okay, so that's probability. Where is it? I'm pretty sure Bayes' theorem is in here. Probability. That's a multiplicative rule. Probability of both outcomes, individuals, conditional. So we talked, so that was what it shows is it's a formula for conditional possibilities and conditional marginal, unconditional probabilities, two conditional outcomes at random. So we're saying the probability of the marginal or unconditional outcomes, the probability of unconditional outcome. So the thing that's not influenced by another outcome is unconditional. Like that would be, so when I say unconditional outcome, so we have our conditional right here. Independent would be an unconditional outcome because it's not affected by anything, right? Mutually exclusive, they cannot occur together, so that would be conditional because they can't, because there's, so I would say independent and say independent primarily because complementary would be, no, independent or complementary would be your unconditional. Mutually exclusive and conditional would be your conditional outcomes. Does that make sense? So what Bayes' theorem is talking about is it's talking about the conditional marginal or unconditional, so let's say the probability of unconditional probability of the outcome. So it's conditional probabilities can also use to make inferences concerning parameters in a given population. So we're looking at the probability of two conditional outcomes that occur at random. So the probability of the unconditional, so we're going so far down the rabbit hole with Bayes' theorem. The unconditional outcome probability times the other probability unconditional outcome divided by the probability of the outcome. So I feel like I'm not explaining this right. I feel like it's just not feeling clear to you. We would rarely use it. It's the purpose would be, let me think. Purpose would be, let's go back to this. No, not that. So we would be talking about like, if we wanted to know, so we have an independent outcome and a complementary outcome. So if we want to know the probability of an independent outcome and a complementary outcome at the same time, we would use Bayes' theorem. Those are unconditional outcomes. So we said this was probably this outcome and this other non-conditional or two different independent outcomes, then you'd use Bayes' theorem. So it's accounting for like outcomes that you wouldn't like the two unconditional outcomes. Does that make sense? It sounds so clear to me, but I'm not sure if it's making sense to all of you. Kind of, sort of, okay. So that was Bayes. We did type 3, bivariate variables. I think that's in chapter 5 also. I'm pretty sure. So let me find the bivariate and then I'll see if I can. That's okay. Binomial. Well, some of it's Greek. Was that in chapter 7? Bivariate? Where the? Well, that was 8. Okay. You have it in chapter 5? Ooh, wait. We're gonna do this. Yes, this is the likelihood. This is Bayes. This is the likelihood of Bayes. This is right here. This is so you imagine they're playing dice in a casino. They have a 1 in 6 chance the night wears on. The dice are turning out more 6 than expected. They adjust their belief. They expect the dice is loaded, so they keep leaving their money in their pocket. Sticking with the gambling theme, consider a professional poker player taking part in the game. Standard probability would state, assuming that all the players are equal ability, have a good poker face. The game revolves with the frequencies and chances of certain cards appearing. However, our players research and study the styles of opposition Yeah, this is base theorem right here, all day long. Okay. Minus. So sticking with the gambling theme, consider a professional poker player taking part in the game. However, she knows that one is likely to bluff a lot, another player is cautious and will not urge to place large bet unless he has a good strong chance of a strong hand, or she or they. The other is prone to making rash bets and going all in. Armed with this information, she can use Bayes' probability to reassess the likelihood of her own hand being strong and the chance of having taken the pot. So it's talking about basically people like your probability outcomes being different, and poker is a good way to like look at it. So like it's those unconditional outcomes because they're all playing differently. That's what you're calculating. Does that help? A little bit? That is 100% this link right here in chapter 5. So we did type 3, we did you want bivariate. I think that's in chapter 8. I don't think that's or chapter 7. Is it here? Don't worry, I got you. Where is bivariate? Just need to see it so I can explain it. Bivariate, sampling. I think it's in this one. No, it's not here. It's 7. This is 7. So maybe it was 8. I don't think it's the 6. Maybe it was 6. No, it should be in the PowerPoints. I didn't see it though. It's binomial. It's bivariate. There. It's gotta be an 8 then. It's gotta be in chapter 8. I just looked in chapter 5. I didn't see it at all. These are publisher slides, like it has to cover everything. It has to. Or I have to look it up, but we'll figure it out either way. I think it's in here. We can take a break. What the hell is bivariate? Size. I'm gonna have to look. Research it. What the hell is bivariate? I swear. Power and effect size. Does anyone know what chapter that's in? I just need to see it. I can totally explain it to you.
I remember seeing it in the book. But I don't remember seeing that.
I might not have explained it to you. Oh, yeah, it's very easy. Oh, it's really simple. It has to do with comparing two variables. So for example, here I can screen share. Or I can tell you after the break, because I know some of you stepped out. But I just looked it up, I just found it, and I found a really simplistic example I can share with you, and it's way easier than it sounds. And that'd be all the WTF stuff, right? Okay. So in about 5 minutes, in case Marina wanted to know too, I'll explain bivariate, and I'll do the worksheet. That'll probably take us to the end. I'm hoping we can get to the worksheet as a class before we leave today. So that way you can all,
Which worksheet is
should be exam 2. Should be student in-class activities. Should be exam 2 review. I should have labeled it. I'm pretty sure I did. Exam 1 review, no. Where the hell is it?
all I see is that where we posted our presentation.
Maybe it's here. No, that's chapters 9 and 10. Activities. No, because I copy the class over every semester, and I totally remember creating an exam 1 and 2 and 3 review on purpose. So because someone had asked for it at some point when I've been teaching stats. Or where the hell I put it. This is an exam 3 review. That's not it. It was literally. That's not that. This is the practice worksheet. I have an exam 2 Word document. I'm positive because I know I remember creating it. Someone asked, or like, can we have an exam 2 review? So I probably just need to go into Word and find it. Yeah, it's worth points. I just try to figure out where the hell I put it because I know it's in here. That doesn't mean I won't find it. Okay. Chapter 12, and that's the deep dive. It wouldn't have been the exam 3 final because that's just the worksheet. I know I put it in there. Because it came up. And I remember, and what was that? You can find. This was the review you guys did. No, it was. I remember creating an exam 2 worksheet, and I'm just trying to figure out why I'm not seeing it. Unless somebody didn't copy correctly. This is in the other class, but I remember they're like, please create this. I feel like I created it like last summer. But it wouldn't matter because it's always been. Doesn't even matter if I can't see the old class because I make an exact copy of the previous class to the previous class so that we always have it. Student resources. Did I put it in chapter 8? Because that would be a weird place to put it. I'm pretty sure I have a worksheet. I seem to remember creating that for somebody. Exam 3 final review. No, that's 9 and 10. Part B. I've sworn. It was one of my worksheets too.
What chapter was that thing we were looking for?
Oh, I just found an example on the internet that's super clear. I couldn't find it. I couldn't find it in the chapter. I'm like, oh, I can explain this. Icebreaker. Where the hell is it? I might not have a worksheet for you. I sworn I created a worksheet because I remember it. Well, it's fine. If it's anywhere, it's on the computer. File, open. Well, I'm going to explain bivariate stuff to you in a second. I'm just trying to figure out where I put that. That would be exam 2. No, that's because I swear I explained it. No, it wouldn't be here. Homework, homework, homework. This would have been the summer. I don't think this would be it. Doubt it. I don't think this is it. This would be something else. Yeah, because we did that for sure. In class activities. No, that's chapter 12 deep dive. Did I not create one because I thought the review worksheets were so clear? I might not have, I swear it. I swear they were like, please give us an exam 2 review. So I was like, okay, I'll create one from scratch. But I don't see it anywhere. That's the form. This is your PowerPoint. But the exam 3 final review might have all of that. I might have combined them. That was chapters 9 through 12. I don't think I have a worksheet. Because unless it was like we really just need the last thing because the F scores and everything else is clear. Yeah, those are weeks 9, 10, 11, 12, which was part A. No, it's only 9 and 10. Was it this one? Chapter 8, no, those are just 6, 7, and 8. So that's the same worksheet. That's 6 and 7. I don't think I have an exam 2 worksheet for you. I don't think I have an exam 2 worksheet. I don't know if you're upset about that or if
But you gave us the study guide, right?
Actually, I didn't see it. Oh, no, you did it individually. Yeah, you did
Remember
it individually, yeah.
Let me
Yeah.
look at my email to make sure
Yeah.
I'm trying to, because if I have that, I'm good.
Yeah. Yeah, we did.
That was so much.
well, I could maybe talk about bivariate analysis and then I might call it a night. Maybe how many more sessions do we have, Jackie? To cover 4 chapters, we could probably do that.
Yeah, we could. I mean, last week we covered 1 chapter and I'm sure we could cover 4 chapters in 6 weeks.
We probably could. And we gotta have a review session. I could have sworn I had an exam,
Yeah.
an exam 2.
Thank you. No.
Exam 2 review. What was that?
On the last 2 chapters, like, lengthy.
Oh, they're more complicated for sure. But usually everybody's like, it's so clear.
Well, especially when
Ooh, wait, chapter 9 review.
I feel like a lot of it builds on top of each other.
There you go.
If you understand the, like the one, the basic.
Chapter 12. If I explain bivariate, how do you guys feel about chapters 5 through 8? Clear, unclear?
I'm pretty clear on it now. The doing a review helped because I had to do my like research while I was typing it and then listening to everybody else's.
Oh, well, I mean, I can explain bivariate and then we could just
Yeah, yeah.
go early.
Yeah.
Like, I won't be upset about it. I've been lecturing since 8 a.m. at multiple schools. This is class number 6. I just want to make sure we get to the material. If we're more efficient and it's what? Yeah. Yeah. Because I still have like 2 more classes to like grade just to stay on top of all the admin. So like getting home early for me is like an incentive. So
It was like full-time. Like,
I
because
work
of
part-time. The job that I was supposed to get, that was supposed to be full-time. I didn't get it,
Yeah, but you have
'cause they're-
multiple part-time jobs.
but I have multiple part-time
So it's like
jobs.
you work like full-time because. you
Yes.
work A bunch of part-time.
Yeah, and the last full-time job was actually less money.
Yeah.
Like the last offer, I was like, well, that's absurd.
I have another professor who's like that, where he works like a bunch of part-time.
Yeah.
Gigs because full-time is like, doesn't pay enough.
Yeah, they were like, I was like, literally, I'm like, that's slightly more than half of all the part-time gigs. Why would I horse trade?
Yeah.
I love teaching. Why would I make less money to do it? That's stupid. And they were like, and you have to quit everywhere. I'm like, no,
Maybe it's because like you have benefits of full-time.
I have benefits now. I have a PPO and I have
Well,
dental.
then that's just ridiculous then.
I- It's $354 every 2 months for 2 people.
Okay.
the government subsidizes it, but I reconcile every year and I never end up owing what the subsidy is.
Yeah.
If I'm real successful, then I could owe it, but it never happens. Or it hasn't happened yet. Let's not jinx it. It could happen next year.
Right.
No, the only thing I don't have right now is vision, but I can get vision in November. But vision's cheap. You can pay cash for vision.
Yeah.
Vision's like $400 a year. Like
Oh, really?
if you just pay cash, it's like $400, $600. That's like contacts, exam, glasses. I mean, it's not that expensive.
Okay.
So
But if you have like more than that, then it's probably more expensive. Get like, I don't know, multiple eye exams.
no, I deal with 1-800 contacts and they have an eye exam you do on your phone.
Oh.
And then an eye doctor signs off on unless your prescription changes. Years ago, it used to be contacts and glasses for the same prescription, and then it changed. And I think it was for doctors to make more money because it used to be the same prescription, and then suddenly they weren't doing that anymore.
Oh, why don't you do LASIK?
Oh, yeah, or you're not qualified anymore.
Because the Simpsons predict the future and everything they say is true, and they said that it was bad, okay? That's why we know student loans are gonna get forgiven. That's not logical at all, but they said, no, we're not barbarians. We're gonna forgive your student loans, so clearly they're gonna get forgiven. They predicted the future for the last like 20 years, and they're usually right. The Simpsons.
That's true.
That- Yeah, they've predicted a ton of stuff. Now, I'm not saying that's very scientific. I'm just saying like they tend to be kind of lucky when they say that.
They've got like an oracle or something.
Yeah.
No.
Oh, that did not work at all. That was like an epic fail.
My dad got that with them.
Can you guys see this? So bivariate data has to do with like studying variables. So you're looking at the relationship between things. So like, for example, like the sale of ice cream compared to the temperature of the day, that's bivariate.
Oh,
That's all it is. Traffic accidents along with the weather on a particular day. Bivariate data as examples in real life. What is the analysis? You determine the relationship between the two variables as X and Y in terms of the empirical relationship between them. Yeah, it's linear regression. So it's the X and Y hat. So basically what it is like give you like a high level summary. It's like if X is 6, then Y is 8. It could be, it's 5, it doesn't, what it is, it has to do with like basically like linear regression, like where you predict is like what's going to happen. We're gonna do I have linear regression. I have an entire video on linear regression that I can probably find in just a second that explains predicting that's what it is. It's based on linear regression. Can I predict what's gonna happen based on that? So if we go to, we can still get out early because I'm gonna find the video, I'm gonna show you, and I'm gonna post it and you can watch it on your own. The Simpsons, which would be linear regression. Yeah, that's what, yeah, that's, yeah. Yes,
what did the Simpsons say about LASIK? Bad?
yeah, Dr. Hubert was like, well, we're just gonna shave off part of your eye, so it'd be just fine. It's like, okay, we're not burning off the cornea. Apparently it's gotten way better.
I
Like,
mean, if you could smell, like, if your flesh is burning, like, I would think of smell it, and I kind of freaked out a little bit. But I don't know if it was the Xanax or the fact that it's just employees that.
oh, actually, I can just pull it up on the screen. Linear. Yeah, yes, I have it right here. Perfect. Because I taught the advanced stats course. I said to find the information. Awesome. Resume share, stop share, start share, linear regression, Microsoft Word. Here it is. Linear regression. The predictor variable is X, the criterion variable is Y. It's used, which is bivariate, because it has to do with linear, you're trying to predict the two. So for example, a job candidate wants to know how quickly a business tends to promote its employees. So he takes a sample of 6 employees, looks at the number of promotions. An example, the job candidate is interested in predicting the number of promotions, given the number of years the employee's been employed. Thus, years of employment is predictor variable X, and the number of promotions is the criterion variable Y. So the bivariate relationship in predicting what's going to happen. use through the use of linear regression. To find the equation of the regression line, we use the method of the least squares, which was first introduced by the French mathematician Adrien Legendary.
Where is that?
Legendary. He's legendary. Am I even saying that right?
Yeah, that means legendary.
Yes. But first we need to ask 3 questions. Is a linear pattern evident in a set of data? So you observe like a set of graph points. Which equation of a straight line can best describe the pattern? Are the predictions made from this equation significant? Analysis of regression. So you have the method of least squares and analysis of regression, and you have the criterion variable. That's what Amazon does. A little bit of linear regression. I think it's a little bit of linear regression. If people, well, it's more like they track the order. So they look at everybody.
Like the thing where like if you like this is most frequently bought with this. So
That would be X and Y, but what they do is an interesting algorithm. You ever got up early in the morning and you order something at like 6 a.m. and you go to work at like 8 and you do 2-day shipping and you come home and you trip over the package? Because what they do is they track all the previous order history for stats and they stack the warehouses nearby. So they're expecting you to order the thing, which is basically linear regression because they're predicting behavior, the X and the Y. So these people order, so there are more and more people are going to order the same thing. That's not quite, it's slightly nuanced because it's X and Y. So that it's like X and X with Amazon, it's the same variable. So you have these 2 variables. Suppose we measure the 2 factors, one predictor variable plotted on the X-axis, one on the criterion, and then we look at the data points, and then we compute the sum of the squares by squaring the distance of each data point from the regression line. I think I have like a video. I have a whole video. I can just point you to the video. And then you guys can go even earlier. Enter the code. 52899. How is it? Linear regression. No, I want my library. No. The hell is my library? My videos. Your videos. So bivariate analysis is a relationship between 2 different variables, like the weather and like traffic accidents, etc. And then my channel content would be right. Should have it labeled, and I can just.
is it like
It says linear regression in there. Chi-squared R and linear regression conceptual. Yeah, because I did that with the graduate course. It's been a little while since I've seen it. So this should be. This is linear regression right here. Yes, it's made for kids, because I'm sure kids want to learn all about linear regression when they're like 4. Okay, so we'll go maybe.
maybe I don't know. Like what if like there's like some math sheet out there and he wants his kid to like know everything.
I have worksheets on this that are in the video that I can email to you. We usually don't talk about linear regression. We just talk about bivariate. So bivariate's like the conceptual relation between the relationships, but it's used to predict what's happening. Where is the other one? Where's the other video? The other video should be right next to it. Yeah, that's because I had to pre-record these for the. Okay, I'll just admit it. I'm a nerd. Okay, linear regression B worksheet. And then this one is the other explanation on linear regression. And I have the worksheets if you want them, but I'm not actually asking you to understand linear regression. It's more about the bivariate analysis, which we can go send a copy. So you guys have that. And the bivariate analysis is right here. And I need to screen share, I think. Bivariate analysis. Yeah, that's absolutely it. We're trying to predict X or Y. So bivariate analysis, for example, two sample data analysis are not the same. So this is it right here. So caloric intake and weight. So we have the 2 sample data analysis are not the same with these.
you can do is two sample is a test in Excel, X and Y are not directly related. There will also be a different number of data values in each sample. With bivariate analysis, there is a Y value for each X. Do you see the Y value for each X? Bivariate analysis. Caloric intake of 4,500 and your weight was 380 pounds. Does this make sense? Bivariate?
Yeah.
This is the X and the Y bivariate. Linear regression is actually predicting what's going to happen, because what you do is you say, okay, we got all these data points. Where do they line up? So they're like all over the map right here. Sorry, Hudaifa, I sent you videos. You draw a line and then you try to predict where they are. So then what you do is you look at like the shortest distance from the regression line, both on the bottom and the top, and then that equals the least sum of the squares, and that helps you predict what X, when X is this is what Y is. That's how you predict that. So that's what bivariate regression is, but all it really is for WTF, the X associated with the Y value bivariate analysis. Linear regression is the next step, but you could actually use that in the real world. You could actually use that in the real world. You're like, how am I ever going to use this? Well, you can start to predict like consumer behavior. Some of that would be like the association with products. If you buy this, you usually buy that. Or you could predict like the likelihood of consumer behavior with one thing or another. Does that make more sense now? What else is unclear for you all? If you want to geek out on it, you can see the videos on linear regression from me. I'm not teaching you linear regression because it's not part of the curriculum.
That's one that you just sent, right?
That's the one that I just sent. And then I have the two worksheets that I explain on the YouTube videos. I can send those to you if you wanted to learn more about it, or you can just watch it either way. Do you want the video? Do you want the worksheets? Would that be helpful? Or you don't know yet?
I don't know yet, but there's nothing attached to the
Oh,
email. that you
yeah,
sent.
there's nothing attached to it.
There's not a link?
No, it's just empty.
Okay, oh, yeah, I know why. I think I know why. Maybe. Can you guys go into, okay, it is there. Click on go into your stats course. Okay, I'm sorry, Daphne, let me make sure to share so you can see this too, okay? Go into your stats course right here. And then if you go into your section, it's right,
Okay, it's
it's
in
in there.
the announcement.
And it's in the announcements, and then that's linear regression, which is predicting. Those are the pre-recorded YouTube videos, because in my grad's course, we do chi-squared and we do linear regression, which is based on the idea of bivariate. And this is like the next level to predict the behavior. So could you use that in a relationship? Would that be awesome, huh? Could you use that in a romantic or non-romantic relationship to predict the behavior of the person that you're going out with, linear regression? You have to have a lot of data points. That'd be a real world application. Or could you predict that with like a loved one or a family member? If you do this, you do that. So
Yeah.
that's your, you feel good about bivariate, or do you want me to dive more head first? Okay, any other questions? Okay, well, since you've all been kicking ass and taking names, you guys can go early. How about that?
When you started college, did you think that you were going to be teaching that?
No, any questions, Raifa? You good?
Oh, yeah, I'm good.